Very welcome you all to this new course of electric drives. Today we are going to start this new course, and as this is our first class, so let me first brief you about the contents of this course. Under this course we'll be discussing about basic concept of electric drives. Then we'll be discussing about how to how to select motors for different applications. Then we'll be discussing about DC drives, AC drives, mostly about induction motor drive we'll be discussing about, and few practical applications. These are the topics or modules to be covered under this course. So before starting our today's discussion, let me tell you what is electric drive or why shall we study electric drive. As you all know, all the motors driven system are there in industrial applications or for domestic applications. For example, if you want to control a cement plant, or if you want to control any domestic appliance such as pump, or for robotics control, everywhere motors are used, electric motors are used. For transportation, electric motors are used. Now it's a trend, recent trend of market is launching electric vehicles. So electric vehicles will also be run on electric motors. So all the moving systems everywhere in process control industry, in manufacturing plant, everywhere we frequently use motors, electric motors, to drive a particular system, a particular part of a system. Now, it is very much important for us to make a precise control of the devices. How to obtain precise control of those devices? Just by controlling the motors precisely. So how can we control motors precisely? Motors could be controlled accurately by means of some power converters. Okay. Now power converters will be controlled by some intelligent controllers. Conventional method of motor control has some drawbacks. That is why power converter based motor controls are much popular nowadays. Analog controllers are also almost obsolete, except some few cases. Analog controllers are being replaced by digital controllers such as DSP, FPGA, microcontrollers, all those. So together, controller unit, a smart controller unit, a good power modulator, a good sensing module, together performs the task of controlling electric motors, and thus it controls a process or a system. Electric drive deals with those entire parts. So today we'll be discussing about basic concept of electric drives. So what is learning objective or learning outcome of today's lesson? To understand the basic concept of electric drives, to get familiarized with function of each component of electric drives, advantages, disadvantages, and application of electric drives. So let us start with first slide. What are the topics to be covered in today's class? First, we'll be discussing what is electric drive. Then we'll describe the block diagram of an electric drive. That block diagram will show each and every part of electric drive by which arranging which an electric drive is formed. Then we'll be discussing about the description or function of each block, why all those blocks are required to drive an electric motor accurately, more precisely. Next, we'll be discussing about choice of electric drives. How to choose an electric drive. There are different electric drives: DC drive, AC drive, chopper fed DC drive, AC to DC converter fed DC drive, then half controlled converter based drive, fully controlled converter based drive, drive with freewheeling diode, drive without freewheeling diode. All those different drives are there. So which drive is to be chosen? When is to be chosen? That will be discussed under the topic choice of electric drives. Classification of electric drives will also be discussed. And lastly, we'll be discussing about advantages, disadvantages, and applications of electric drives. So let us start with what is a drive? See, as written here, motion control is required in large number of industrial and domestic applications like transportation system, rolling mills, paper machines, textile mills, machining tools, fans, pumps, robots, washing machines, etc. So there are wide area of application of industrial or domestic motors in order to control motion to run a process. Now, to run a process, motors are required. It may be electric motor or it may be hydraulic motor. It may be any kind of motor. But these motors could be driven by some electrical drives or could be driven by some petrol engines, gas turbine, steam turbine. So the main function is to drive those motors so that mechanical energy could be produced and motion could be controlled. If a system employs different petrol engines, steam turbines, or gas engines, all this, then it would be called a drive. But if it is controlled by means of electric supply, electric power, along with electric motors, then it would be called electric drive. So electric drive would be discussed in next slide. So initially, at the very beginning stage, electric drive was not there. Initially, there were manual drives, there were petrol engines or gas engine or steam turbine, steam engine based drives. But later electric drive was introduced. So how electric drive works or what is electric drive, that let us now discuss. What is an electric drive? The drives employing electric motors are known as electric drives. These electric drives run with power supply. So power supply is an essential component of an electric drive. An electric drive can be defined as an electromechanical device for converting electrical energy into mechanical energy to impart motion to different machines and mechanism for various kind of process control. What does this mean? Our main objective is to control motion of a process or of a device. So in case of electric drive, we use electric power supply. So an electromechanical device is required which could convert the electrical energy into mechanical energy to impart motion to different machines. And whenever different machines are driven by some mechanical energy, it will drive the system or the process. So what are the basic components of electric drive? This is block diagram of an electric drive in which an AC or DC source is there, which is fed to a power modulator. The power modulator will run the motor. Motor will run the load or process, whatever it is. Now, whether motor is operating as we desire or not, to check that, a sensing unit is needed. This sensing unit will sense whether motor torque or motor speed or motor current is as per our requirement or not. Depending on that, depending on sensor's value, this sensing value will be sent to control unit. Now, what control unit does? This control unit works as brain. It controls the entire system. How, that we'll discuss later. What input is this? This is an input to control unit. This input is generally of low voltage, and this could be considered as command signal. This command signal will tell a control unit that we need this desired response. So depending on input provided by input block to the control unit will start its work. Suppose, for example, you want 1500 RPM of the motor speed. So to rotate this motor at 1500 RPM, what you need to do? You need to provide an input signal to the control unit that you need 1500 RPM. So this input unit will provide the controller or control unit a signal which is the desired response of the user. So user desires a particular speed that is sent to control unit. Now, based on the input received from the input block, the control unit sends a signal which is a low voltage signal, low power signal, to the power modulator. Now this power modulator will work accordingly and will drive the motor, will send power to the motor. Which power? This power modulator cannot produce any power. So which power it will send to motor? This power modulator is generally comprising combination of different switches. Depending on this control signal, this switch may be on or may be off. So suppose you want more power at the motor, then this switch should be closed for a long time, for more time. If switch is closed for a more time, then the motor will be connected to the source for more time, and average power consumed by the motor will be more. So suppose that this motor is rotating somehow at 1400 RPM, but you desire the motor to operate at 1500. So this 1400 RPM will be sensed by the sensing unit. So sensing unit will send 1400 RPM to the control unit. This input block constantly sending 1500 RPM. So this control unit will now decide, subtract these two values. This is desired value, this is actual value. Subtract these two values, and depending on the error, this control unit will send another signal. This is continuous signal actually. Signal to this power modulator, and based on this control unit signal, on off time of this power modulator will be modulated. As on off time is modulated, so motor will get modulated power at its terminal, and motor speed or torque or voltage, whatever you want to control, could be controlled precisely. So these are the basic blocks of an electric drive. Now we'll be discussing about each block, and we'll discuss what's function of each block. Load used in the block means, suppose you want to rotate your ceiling fan. Okay, ceiling fan comprises a single phase induction motor, and the blades of the fan could be considered as load. Pumps, washing machine, all these are loads. A body of robot is load, which is driven by different motors. Okay. Now, what is power modulator? This is very important part. Power modulator adjusts or converts the power flow from source to motion. So modulator converts power flow from the source to the motor. Now, this power modulator not only sends power, controlled power to the motor, it also does the conversion operation. Suppose you have AC supply. Suppose you have AC supply here, but this motor is to be run, which is DC. So for DC motor, this should accept DC power. So this power modulator can also convert AC input voltage into DC voltage. So this power modulator not only modulates power, it also converts whenever needed. What is motor? This motor is actual energy converting machine. We have electric power supply. Power modulator modulates that power supply, power of the power supply, and sends it to the motor. Now what motor does? Motor takes electrical energy and converts it to mechanical. Thus, load could be driven. So motor could be treated as actual energy converting machine. Next is source. Source is, as you all know, it supplies power to the entire system. Now what is control unit? This control unit does the entire controlling part. It controls the on off of power, on off of the switches of power modulator, and thus controls motor speed, motor load characteristic, motor switching starting characteristic, motor torque, motor voltage. Everything could be controlled by the control unit, and control unit works via power modulator. So to get a desired response of the system, the control unit should play a vital role. What is sensing unit? Until and unless sensors work together with control unit, controller alone cannot perform any task, because the controllers will work based on two inputs. One is desired input, which is command input. Another is sensor input. Controller continuously compare these two inputs acting to the controller and decides as per the instruction given by user. Now what is power modulator? Power modulator, as discussed, power modulator regulate the power flow from source to the motor to enable the motor to develop torque speed characteristic required by the load. So every load may have different torque speed characteristic. So power modulator will enable the motor to get that torque speed characteristic which is desired by the load. What are the common functions of power modulator? The control of the source, they control the source and motor currents within permissible limit during the transient operations such as starting, braking, speed reversal. That means at the time of starting, as you all know, starter is needed to reduce starting current. At the time of starting or braking, a huge current could be drawn by the motor. Power modulator will reduce that limit to a safe value so that there is no damage of the equipment. They convert input electrical energy into the form as required by motor. As I already said, suppose you have DC input, you have DC supply, but you want to get an AC motor to run. So what shall you do? You should place an inverter in the power modulator block. So power modulator block will invert the DC into AC so that AC motor could be run. Okay. The power modulator adjusts the mode of operation of the motor, that is motoring, braking, and regenerating. So whether motor should work in motoring mode or braking mode or regenerative mode, that also could be operated by power modulator. Now, what is inside of a power modulator? Power modulator generally comprises different power electronic converters to regulate power required by motor and load. It also converts the form of electrical energy. AC form of energy could be converted to DC. Unregulated DC could be converted to DC. Unregulated AC could be converted to AC. Anything. So there are following types of power converter: AC to DC rectifier. So AC to DC rectifier is used to run a DC motor with AC supply. Now, this AC to DC rectifier could be having different combination of switches, such as this AC to DC rectifier could be of uncontrolled type, controlled type. Bidirectional power flow could be controlled by this AC to DC rectifiers. This AC to DC rectifiers could perform power factor correction operation. This could be half wave controlled rectifier, full wave controlled rectifier, or fully controlled rectifier. This could be midpoint converter. This could be semi converter. This could be AC three-phase rectifiers or single-phase rectifiers. So different forms of power electronic converters could be used based on the type of motor, type of power supply, and requirement of the motor. Next, DC-DC chopper. Suppose you have a fixed DC. You want to get a DC motor run. So what you need to do? You need to control the fixed DC, or you need to regulate the fixed DC to a variable DC. For that, choppers could be used. So different types of choppers are there: step up chopper, step down chopper. Based on quadrant operation, choppers could also be classified as class A, B, C, D, E chopper, multi-quadrant chopper. There are voltage commutated chopper, current commutated chopper, etc. AC voltage controllers could also be used, in which a fixed AC voltage could be converted to an AC, which is a regulated voltage. So back-to-back connection of thyristor for AC voltage controllers are very much popular. Cycloconverters could be used. By means of cycloconverter, you could control the speed by controlling frequency of the supply voltage. Cycloconverter could be step-up cycloconverter or step-down cycloconverter. Inverters could be used. Suppose you have solar power and you want to run an AC motor with solar power. Suppose you want to run induction motor with solar power. So an inverter is needed in that case. So there are different types of power electric converters used in power modulator of an electric drive based on the requirement of load, availability of supply, and motor. One more thing, power modulator has switches which are having generally three terminals. Two terminals are power terminal, one is control terminal. So control terminal is associated with low voltage. So control terminal could handle low voltage or low power, whereas power terminal could handle high power. So a single device is designed in such a way, such as IGBT, power IGBT or power MOSFET, that its two terminals are capable of handling high power and one terminal is capable of handling low power. Next is control unit. This could be considered as heart of the system. The control unit is mainly used to control the power modulator. As I said earlier, the control unit regulates the motor actually by means of power modulator. So what control unit does, control unit sends a signal to gate terminal of switch of a power modulator, and by depending on that signal, power modulator will be turned on or switch will be turned on or off. If the control unit sends a more width of the pulse of the control pulse, then power modulator will be turned on for a more time, and less pulse width will enable the power modulator for the less time. So you already have started PWM operation. So how PWM is generated? PWM is generated by control unit, which is later fed to the gate terminal of the power modulator switch. This unit sends control signal to the power modulator based on which the modulator operates. This unit produces the rules for safety of the motor as well as the power modulator. So based on this control signal, power modulator and the motor could run safely. So control unit is a smart controller in which lots of instructions are written. For digital controller, lots of programming codes are given which gives actually instructions, and those instructions are given by user. User study the motor and power modulator initially, and based on that, user knows what are the precautions to be taken for safety of power modulator and the motor, and based on that the instructions are given to the controller. So control unit works based on those instructions. So those control units actually produces the rules for the safety of the motor and as well as the power modulator. Presently different digital controllers are used, such as microcontroller, DSP, FPGA, to provide better accuracy, faster response, all this. Now what is sensing unit? Sensing unit generally comprises different sensors. Nowadays sensorless controls are also there. I'm not going into that. A particular motor could be sensed in terms of its speed, its current, armature voltage, torque, all this. So there should be some mechanism or some device which could sense all these parameters, and those parameters are first sensed by sensors, and then sensor will send that signal to the controller. This sense signal gives the controller actual operating condition at that time of the motor, and based on that actual response of the system or motor, controller will take control action, and control action will be taken based on the input or command input given to the controller and instructions written in the controller. The output of sensing unit works as feedback to the input, feedback input to the controller. The controller checks the deviation in command input and sensed output, and based on that passes an instruction to the power modulator. This shows an image practical power modulator and control unit. See here, this power modulator comprises different switches. These switches could be connected as inverter or as converter or as chopper, whatever. Now all these switches are having 3 terminals, 1, 2, 3. One is gate terminal and remaining 2 are power terminals. Now these switches are continuously operating for a long time, so these switches may get heated up. That is why, to keep the switches cool, this heat sink are required. So design of heat sink is another part of study. I'm not going into details of that. So heat sinks are required to cool down the power switches. As these power switches are handling high power, so this may get heated up after some conduction time. This part is control unit, which comprises different ICs, pots, potentiometers, different capacitors, resistors, transistors, diodes. So this is the control circuit which sends a control signal to the power modulator. This could be considered as analog control circuit, which could be replaced by microcontroller based control circuits as well. Now, what are the factors influencing the choice of electric drives? Nature of electric supply, whether DC or AC is available to us. Nature of the drive, whether DC motor or AC motor is to be driven. Capital and running cost, maintenance requirement, space and waste restriction. Sometimes this may happen that your consumer could or customer could ask you to make a drive within a 5 feet by 5 feet area. So based on that space, you have to build your drive. Also, weight of the drive is required. Suppose you are going to design an electric drive which would be used in electric vehicle. So that electric drive should not be of much weight, because bulkier electric drive, it's very problematic to accommodate a bulkier and spacious electric drive to an electric vehicle. Weight and space, both will restrictions would be there. Environment and location, nature of load, which type of load is to be operated, electrical characteristic of motor such as starting, braking, all those, size rating and duty cycle of motors. So these are the factors influencing choice of electric drives. Now, classification of electric drives: group drive, individual drive, multi-motor drive. So what is group drive? A single motor is used to drive 2 or more machines. So for a group drive, the motor is connected to a long shaft and all the other machines are connected to that long shaft by means of pulley, belts, all those. So there are few advantages and disadvantages of group drive are written. A single motor is used instead of number of small motors. This is economical because the rating of motor used may be comparatively less than aggregate of individual motors required to drive each component. Initial cost is also reduces, but it has some drawbacks as well. It is less flexible. Suppose you want to add some more machine to that particular industry, you cannot do that if the industry is working with group drive. That means, suppose initially you have 20 loads which are connected to a particular motor. Now, if you want 50 loads instead of 20, if you want to increase your load, that you cannot do, because suppose that motor is designed to drive maximum up to 30 loads. So you cannot increase it beyond that. So that is limited. High level of noise will be produced. As a single machine is running, it will produce a high level of noise. As all the elements are connected to a single shaft, all the loads are connected to a single shaft through belt and pulleys. So there will be a considerable loss in belt and pulleys. It is less safe to operate as it will draw huge current. Now, what is individual drive? In case of individual drive, separate driving motor will be used for each process equipment, such as for lathe machine. What are the advantages? Machine can be located at convenient place. Whenever required, it could be located. Continuity in the production of the processing industry ensured with high level of reliability. In case of fault of one motor, the entire system will not be affected. But it has one disadvantage, that it requires high initial cost. Now, what is multi-motor drive? Multi-motor drives are used in cranes, robotics, all those, where separate motors are used to actuate or to drive a particular driven mechanism. For crane, separate motors are used for hoisting, long travel motion, and cross travel motion. These are the advantages of electric drives. You just need to go through it. The electric drive could produce large range of torque, speed, and power. Their working is independent of environmental condition. These are pollution free. The electric drive could operate in all the 4 quadrants of speed torque plane. The electric drive can easily be started, and it does not require any refueling. The efficiency of the drive is high because loss is less in electric drives, as there is not much involvement of large mechanical devices. There are some drawbacks of electric drives as well. The application of drive is limited because it cannot be installed anywhere. Suppose you are at a remote area where power supply is not available. There you cannot install an electric drive until you made some power supply arrangement. It can cause noise pollution. The initial cost of the system is very high. It has poor dynamic response, although the dynamic response could be improved by using smart controllers. During the breakdown of the conductors or short circuit, the system may get damaged due to which several problems may occur. But this short circuit problem could also be taken care of by some productive means nowadays. So these are applications of electric drives. Electric drives are applied everywhere. In traction, electric drives are mostly used. In traction means where transportation of material or transportation of us could be done by means of electric trains, electric buses, trolley, solar powered vehicles inbuilt with battery, to put more emphasis on green energy, green environment, to reduce global warming. The entire world is working behind electric vehicle now. So once this is in market, the transportation industry will have a huge shifting from automobile to electric vehicle. Their applicability of electric drives will be much more increased. Electric drives are extensively used in industrial domestic appliance applications, such as in different factories, pumps, fans, robots. The electric drives could be used as main movers for petrol or diesel engines, turbines like gas or steam turbine, etc. So today we had discussed basic concept of electric drive. What is an electric drive? What are the basic parts of electric drives? What are the function of each block? Classification of electric drive, how to choose electric drive based on different factors, what are the advantages, disadvantages, and application of electric drives. So as of now, today I'm ending up here. Meet you in next class. Thank you all.